All right, we're live again. Well, I think we all have some overall questions from what our pre-discussion went through. So I don't know. What's everyone kind of confused on? Because, like, I get that the sigma is unknown. That's the standard deviation is unknown. We get that.
And that's like the big difference between what we had been doing last time and this time.
Mm-hmm.
They introduced the whole idea of degrees of freedom, which I have no idea.
Well, that one you have the degrees of freedom has to do with the new applet that they gave us.
There's a new applet?
Yeah.
Yeah.
It looks like.
Oh, I pulled up an old one.
Here you go. Here, I'll show you what the new one looks like. Oops, wrong one. Screen
I just put the link to it in the chat.
It looks like this. At the very beginning, there's talk about and then you put the degrees of freedom up here, and that kind of that'll help it varies things on it.
Where did you say you put the degrees of freedom? Can you point at it again?
Right up here, it says student probabilities with blank degrees of freedom.
Got it. Okay.
And
then I will close out of that other one.
No, we're gonna need that one too.
Oh, well, I'm gonna open that one right back up.
Yeah. But yeah, so.
Okay, so what do the degrees of freedom represent?
The degrees of freedom represents how the arc is going to look, I think, or what we're going to do that way. The other thing we're going to need is this guy, because you're going to pull the degrees of freedom from right here.
Okay, yeah, so I have that guy open.
Yeah.
So I'm really just kind of going right down the preparation assignment. That big, long, ugly formula that was the answer to number 3.
There's Cody. Are we going to get him today?
Go.
Are we going to get him today? No, it doesn't look like he's still muted and no. I'm going to stop screen sharing here.
Okay.
There we go. Let's see. Sorry, guys. No one can help me out. Sorry, bud.
One of these days we should just, like, I'm always on campus doing this. Cody, you're on campus, right? You're in Rexford. Yeah, so we could even meet up one of these times and we could both just
sit in on it.
Sit in on it.
Share the conversation.
I'm just sitting here. I'm usually either sitting here in the library or in the eye center, so either one works.
Oh, guys, I have good news. My degree is still going to be a BYU Idaho degree.
Oh, good.
Nice.
Yeah, I was really concerned about that one. Okay. So, do we want to go over the preparation, or do we kind of just want to dive into the thing?
I think it might be a good idea to at least go over it.
Okay. Yeah, let's do that.
Well, Brooke, were you saying personally you'd rather skip it?
I mean, I'm fine with just going straight into the quiz and trying to figure it out there. But if someone else has like a specific question that they want to go over first, then let's go over that first.
I don't really have a specific question. I just know that I don't feel very comfortable with the material.
Yeah.
I think doing it this way. I think going straight into the quiz will help a little bit more because it kind of gives us a little more of a.
Okay. Let's do that then.
That's just me. I don't know.
Well, hey, I'm all for it, and I got to be done here before 9, so whatever makes this go quicker.
Okay, actually, let me grab my charger real quick, and then we'll get rolling. Okay, guys, pull your stuff open, and we'll get going. What do you do? Downward dog.
Yeah, Spencer, he doesn't walk. If
I
he
know.
can stand up on his own without any help, we're screwed.
My little guy just about stood up on his own.
Oh my gosh, kiddo.
Okay. You guys get everything pulled up?
Yeah.
Okay.
Okay. Is it cool if I start us off here?
Yeah, go for it.
Okay. Question number 3. In previous lessons, we had assumed the population standard deviation was known. In this lesson, we are making a different assumption about the standard deviation. What has changed? So we assume that it is unknown.
Yes.
Okay. For the next 2 questions, let the null and alternative hypotheses be null, the mean is equal to 8, and alternative, the mean is greater than 8. Assume that the population standard deviation is not known. Becca collects a sample size of 9 and computes the sample mean to be 11. And what is S?
S is it's the sample standard deviation that's calculated, I believe.
Yep.
Okay, so in this one, is the standard deviation known? Is that a trick question?
No, it's not known. It says even at the beginning, because sigma is not known, but S is known. Make sense?
Okay, so what's the difference between sigma and S then? I guess is my question.
That's a good one.
That's an awesome question.
S had to do with, you know how you find S? S is when you put in is it S on this one? Yeah, standard error of the mean. Or is it that, or hold on? I can't remember if it's the standard deviation or the standard error of the mean on the one sample t-test. But so when you put it into the calculator in Excel, well, it shoots out the S. So
Okay.
Where is the S in?
I can't remember if so. It's in
Is it the
variable
standard
one.
error of the mean?
I think it's that, but I can't remember.
Let me look it up real quick. Well, standard error is not even listed in the entire text, so never mind.
Let me see. I'm going to.
Okay, cool. So number 4 is no, it is not known.
No, it's not known.
What is the value of t? Okay, do we plug all this information into that?
So you plug it into it's the
I'm on a group meeting.
it's x minus mu divided by s divided by the square root of n. Which this is where I wasn't. So let's see. It's in this situation. It would be 11 minus 8 divided by 6 divided by the square root of 9. So would it be 1.667?
I got just using your formula you just said. Did you?
It's the one from the. I have this one wrong. This one I got wrong. I couldn't. I have 11.
I got 1.5.
That was the other thing is I pulled a couple of different answers for this one and I'm not 6 and 9. Because the answer I put was 10.556. But that wasn't right. let me see here. So it's equals 11 minus 8 divided by 6 divided by the square root of 9. See, without parentheses on Excel, I pulled 10.5556.
I'm setting up a model right now in Excel that will calculate it for me. Hang on. Yeah, I got 1.5 as well now with my Excel.
Oh, that makes, sorry, yeah. Mm-hmm.
Okay.
So
What did
you do on your, oh, so it would have to be, hold on, so these, I'll put in.
So I just did 11 minus 8 divided by 6 divided by the square root of 9, which is 3, and I got 1.5.
Yeah. I don't know why in there it's not
I
pulling
just
it
plugged
right.
into Excel now and don't know what the formula is, and it gave me 1.5.
Yeah.
Cody also got 1.5.
Yeah. What is this? Oh. Okay. Next question. So we have to put all that information into the thing.
This is a test of your eyes being good more than anything.
Yeah. I got 98.22.
Yeah, that's what I have, and that answer I got right.
What are we? Okay, so it's asking for the mean first.
Yeah.
Okay, I got the same thing.
4.
So 98.22. Do we? Okay. So
Wait, Mitch, what did you get for number 6?
The same thing you guys did, 98.22. Is that what you said?
Yeah.
Okay. So with S, are we going to assume that that's the standard error of the mean?
What's the answer?
I got
Like what?
0.206.
0.206. Let me see what I put in. Yeah, I think so, because it wasn't the standard deviation, because I put the standard deviation in there.
Okay, do we need to fill in just the values on the left, or do we need to fill in like the summary statistics and everything too?
No, I don't
have all that information.
Oh, you know what? Oh, do we have it? Yeah, we do.
Well, we have
No.
a null hypothesis and everything.
I think at this point now.
Then we have that. We have a level of significance, but I don't think we put that. Yeah, that doesn't go into here. Okay, so for S, then I'm just going to put 0.206 for number 7.
Mhm.
T-score negative 1.843.
Give me 1 second. I didn't get all the information yet. 7,
Okay.
97.6. Did you say you got 2.06? I don't know if I entered some of this in wrong. Yeah, there we go. So then the T-score, what did you get for the T-score?
Negative 1.843.
Where did you get that number from? Oh, because you put it into the thing, huh?
Mm-hmm.
You put it in Deer. So, okay. So negative
Negative
1.
1.843.
1.483. Okay. What's the p-value? The p-value. So we put this into the normal probability.
Well, I think the p-value is also just, doesn't it also spit that number out?
Yeah, but it shoots it out really teeny tiny.
Well,
Like
I have like 0.081 isn't our answer.
Where did you pull 081?
So I plugged in using the quantitative inference procedures thing, the spreadsheet that we downloaded for this one.
Mm-hmm.
And then as soon as I plugged all of those variables in, the 97s, 98s, 99s, those numbers, it spat out the S, the T-score, the p-value, confidence.
Because the p-value that I have is 1.28234. What's scientific notation? E negative 39.
So when I plug it into the new applet thing, I get 1.84 or point. Wait, hold on. What was your number? It was 0.0813, right?
Yeah.
Okay. So if you put it into the new applet, then that's how I got 0.0813.
Where into the applet does it go? Oh,
So
you put the t-value in. Okay.
Yeah, like I just put the t-value in, and I got 0.0813.
So, but what degrees of freedom did you put in?
I have 3 degrees of freedom. I probably need to change that though.
It needs to be at 19.
Yeah, okay, so what section do you shade under the...
That's what I'm trying to...
Okay, yeah, so it's using the probability applet. It spits out the correct p-value for you already using just the spreadsheet.
Okay.
Wait, maybe I'm lying. Maybe I am lying.
Okay.
Okay, what are we all thinking?
The p-value is the area in the two tails beyond the test statistic, t. In other words, the p-value is equal to the two tails.
So 0.081.
Why do you get 0.081 though?
So if you plug 19 degrees of freedom in, and then I put the t-value of negative 1.843 in, and then if you highlight the two tails, the area comes out to 0.081, which is also the same p-value that was calculated on the spreadsheet.
I don't know why my p-value is not coming up properly though. The null hypothesis. Do I have to change the null hypothesis in there?
Yes, you do.
What? So the null hypothesis is that's why
98.6. Yeah.
the null 98.6, and then it's what's the so let's see, and that's the null or the alternative is less than. Right, and then the confidence is. Did you put the mean, standard deviation, and n in there or no?
So I didn't put anything else besides the null hypothesis in there.
And you didn't change the type of test?
No.
Because I need to double. I don't know if I put the numbers in wrong. That's just the thing. I don't mean to be keeping everyone up. I'm just really confused why. So I have 98, 99.6, 97.8, 97.6, 98.7, 98.4, 98.9, 97.1, 99.2, 97.4, 99.1, 96.9, 98.8, 99.9, 96.8, 97, 98.7, 97.6, 98.7, 92. Yeah, they're all right. Confidence level is 95. 98.6 is a null hypothesis, and the test type, it would be that the be less than, wouldn't it?
Where did you get your 95% confidence?
That it's a that the level of significance is 0.05. Oh, you know what I've been doing? You said 98.43, right? Or 1.843?
Negative 1.843, yeah.
I hate being dyslexic sometimes.
I'm not dyslexic, but you're gonna believe me.
I'm not actually dyslexic, guys. I just have an issue with it sometimes. Okay, 0.081. There we go.
Yeah. But the fact that now that I'm looking at this spreadsheet, I don't know why, because if we do, it would make sense that we're supposed to change the type of test to a less than test, in which case the p-value changes. But then on the probability applet, if we just do, as is, I think based off of what you read, I don't think we should put anything there.
I think I was reading instructions for just a certain thing, that it is just going to be, it's a one-sided test. It's not an equal to kind of thing. You know what I mean? So it could, or that it's not equal. It has to be one of the other sides. So a 0.0405 would make sense as the p-value. Make sense?
I completely agree.
So our p-value, the S is still 206. So that our t-score, so our p-value would have to be 0.04.
0.
How do we get the 0.040?
Because it's a one-sided test, so you only need one of the sides. You only need one of the tails. I think because I was reading instructions from the wiki,
Okay.
so it's a one-sided test. Makes sense.
Wait, but
That's-
shouldn't it be 0.041 then?
No, because the p-value on, if you look at if you change on the calculator the type of test to a less than test, it comes out to 0.0404818822. So if you're basing it off of that, you wouldn't round that. You wouldn't round the 0.
Okay, I guess I'm
probability-
looking at like the applet and it's 0.0405.
I think
Right,
because you're
and
supposed
the
to pull.
applet, based on the way that the applet rounds, it does it a little bit different. But if you do it in Excel, which is going to be a little bit more accurate, and if you pull out the decimal places, it's like Spencer was saying, it's just 0.040.
Okay. Got it. Question 10. What is the correct decision based on this evidence?
That's a great question.
You reject the
Spencer.
null you reject the null hypothesis. This one is you reject the null hypothesis because the p-value is less than 0.05.
Okay. All right, now we have another thing to plug in.
Yep.
Oh, really?
Yep.
Oh,
Yep.
shoot.
The last one. There's only 2.
But these numbers
Okay.
are a little easier to differentiate between.
Okay, good. This was a really good idea, just jumping into it. This makes so much more sense doing this.
It kind of gives you a better guide sometimes.
Totally, yeah.
So then this one, we're going to want to change the null hypothesis to 40.
Mm-hmm.
The confidence level to 0.99. And the type of test to not equal.
Okay, so you keep. Why do you keep changing the confidence level? I don't see why you're doing that.
Because the level of significance.
The level of significance is 0.01. So we would do
Confidence level is
1 minus. Yeah.
So is the
0.01.
confidence level just the 1 minus that?
Yeah.
Yeah.
Oh, I didn't know that. Okay.
All right. So the p-value on
Okay,
this
so
one. Oh, go ahead.
I'm getting a p-value of 0.995.
Same
Yep.
here.
Therefore, we failed to reject the null hypothesis. So if we change it to the next one is the mu is it's decreases.
Decrease.
So now you reject the null hypothesis.
You still failed to reject the null hypothesis.
What's the rule with that again? If your p-value is greater than your confidence level?
Give me 1 second. Sorry. So decreases and you fail to reject. You still fail to reject it because it does go down. It splits in half, but it's still not. It's still your confidence level is still, or your what's it called?
What's it called in school? They're gonna keep it. I don't know if you told.
What? What?
What was that?
Sorry. So the p-value splits in half, but it's still more than what the what's it called is the level
The
of significance.
confidence. Do you compare the level of significance or to, I guess,
The level of the level of significance, not the what's it called. Now construct
Okay.
a confidence interval for the true mean wait time. So you change the confidence level to 90 or 0.95. They are.
Yeah.
So what is the lower limit on the confidence level? Oh, go ahead.
So then for question 15 and 16, I'm getting 23.499 and 56.597.
Yes.
Wait,
Okay.
hold on. Oh, so that, okay. Yeah, I see where you're at now.
Okay. I don't know if someone wants to. Well, whenever you guys someone gets a chance.
Okay.
If they
Yeah,
want to
I
submit it.
can submit that. I can submit that.
Oh, no, he did try to stand up on his own without any help today. Yeah. He went downward dog by himself, like legs straight up and his arms holding the rest of his body in the middle of the living room.
Okay, we missed one of them.
Which one?
Let me go back and see. We missed number 7.
Yeah.
Number 7?
Yeah, it's not. We don't know what the S is.
Uncle Connor comes tomorrow.
So let's see. Oh, that kind of sucks. So
Yeah.
need to put all the info back in. 98.
Got my couple of Popeyes. So they can see it. Where are they? Where did they go? Oh, look, this is easier. Daddy's so bigger. You can see him bigger. Oh, there. There you go.
Where are you going?
Where's Dada?
Okay, so S stands for the standard deviation of a sample.
Those artichokes the other night? Yeah.
So I think we need to take the standard take our standard deviation and
Yeah.
do calculation. Where is it? Oh, I thought I had it on here.
Yeah.
I think it's just the standard deviation.
Yeah, it's just the standard deviation that comes up.
Yeah, so if you do the standard deviation, so equals, hang on, equals standard deviation divided by the square root
Cucumber salad.
of the sample size.
Peter pockets.
I'm sorry, is somebody inputting all the other answers real quick?
Yeah, I did.
Okay, so what was our standard deviation that comes up?
The 0.922.
And what was the sample size?
It was 20.
Okay, so 0.922 standard deviation.
And then you divide that by the square root of 20, right?
Yeah, so then I'm getting 0.206.
I could have sworn they took it. I was pretty sure that they had taken it.
Oh, and that's what we put.
I don't know, but they took it home.
Go ahead, Google, you're failing me.
Because I know it's not the 0.922 or 0.922. That's the answer I put initially, and I got it wrong. Oh, you know what? I think it
And
is.
it's not.
No, I think it is point 0.922 because I put 0.992.
Yeah. So Brooke, I guess you're kind of you're the next one in line.
Yeah, so it's supposed to be 0.922.
Yeah.
Okay. Let me go ahead and submit that.
I'm glad they found it.
Because I couldn't find it online. I saw that it was, at one point it was only.
That was it.
Okay.
Okay.
Yeah,
Is it
question 7
clear?
should be 0.922.
Okay.
$20.
Okay. Is it
Oh,
cool if
wow.
we go back through those real quick so I can submit again?
Yeah.
Yeah.
Do you want me to just read them off to you?
Yeah. Hang on. I'm
Or-
opening it again right now.
It says it was not making sense. I mean, I was upstairs, I was downstairs, behind the couches. Hi. Hey.
I'm glad they found it though.
I heard where she found it, but anyway, look, there's.
Okay. I'm ready whenever you are. Brooke.
Okay, so question
What?
3, we assume that the standard deviation is unknown.
Oh yeah. I have one in the
Question
dryer.
4,
I need to get to it.
question 5, 1.5,
Nice. Yeah. I
question
don't have
6, 98.22, question 7, 0.922,
Nice.
question 8, negative 1.843, question 9, 0.04,
He's
question
so
10, we're going
playing
to
with
reject the null
today,
hypothesis.
And it was just.
Question 11, 0.995.
Difference.
Question 12, we're going to fail to reject the null hypothesis.
What's she gonna
Okay.
get?
15, decrease.
Oh, he figured out that the.
Question 14, fail to reject the null hypothesis. Question 15, 23.499. And question 16, 56.597.
Thank you very much.
Let me know if you need any of those repeated.
I just submitted it all, so
I know, before I
guess
know it, I
regardless
don't
of if it's right or
want
not, huh?
All right. Well, Cody, you got anything for us? No. All right.
He's good.
All right. So look, you
So-
Everyone.
Yeah, next week, Tuesday and Thursday, I'll go ahead and set up the meetings.
sounds good.
Sometimes he'll say in the bubble.
Okay.
All right. We'll plan on seeing you guys.